All right, moving on in the schedule here, we're going to go to Gnosis, and we're going to talk about Gnosis Safe SDK. So, Richard, you here? There you are.
Yes.
Good to see you. How are you?
I'm fine, thanks. A little bit cold in Germany right now, but besides that.
Yeah, it's come to Denver.
If that would be that easy right now.
Yeah, it wouldn't be, but you're sort of in Denver virtually right now. So we're going to go ahead and give you the stage.
Cool, thank you. Hey, and welcome everyone. I want to give a short introduction to the Gnosis Safe Apps SDK and our related bounties. So I think we already had a presentation like a couple of days ago from one of my colleagues about our bounties, and one of our bounties is very centered around the Gnosis Safe Apps, and therefore we want to give a short introduction and show you how to get started with it and reuse your existing code to write a simple safe app or whatever safe app you want to write for the bounty. So I think the first thing I just wanted to show exactly like what are safe apps. So for those who don't know, so the Gnosis Safe is a multi-signature wallet so a contract-based wallet where you can manage your assets. This is a Rinkeby version that I hope everybody can see. And there you can set up multiple owners that then together, or like actually it can be also multiple keys of one person that together, and these key together manage the safe, and you can use them. Obviously, integrating multi-signature wallets like MetaMask into different apps is a little bit tricky. Therefore, one of the ways that we are currently using it is that we allow that you can basically write small apps or small decentralized apps that can be used within the interface. So one of our very straightforward examples, like this transaction builder, where you can basically just perform, like you can build together transactions, and that can be sent over your multi-send. And actually here we could even like take advantage of some of the features of the multi-send contract, and we can actually also batch together transaction multiple into one. As you can see here, we could then send multiple. Yeah, and today we want to see how can you write your own safe app, and how can you take advantage of the smart contract features of this and can get started. So as a very simple example, we want to start with a React app, and we would assume like I want to get started on the use case that you have written a decentralized React app that you just want to migrate, or where you at least want to copy quite some of your code. So for this, I took a very simple example for a React app where basically allows me to connect my account. It just then does some fetching in the background, and then it shows me for all kinds of tokens and spenders the allowance. So these are all the allowances that I have set on Rinkeby. I think most of us are used to this, that I don't know, if you use Uniswap, you have to set really high allowances so that the Uniswap contract can make use of this. And so most of us have set up some of these allowances for some contracts, and I'm not sure if everybody is aware of their own allowances. And you can basically click the reset button, and then you can reset it, and you see the nice, I'm not sure if I hope you see the nice MetaMask pop up, where you can then see actually what we're doing here is we set the permission to zero, back to zero, so that these allowances cannot be arbitrarily used by other apps. So this is all nice and cool, but this also, like, first of all, don't judge my design. This is just very bare bone example app. But yeah, so if you would now want to use this with our safes, this would be very tricky. And actually here also, if you want to use it with an EOA, right? If you want to reset all of our allowances, we need to click one after each other, sign a transaction, and send it. So for the small example, I'm going to take the safe app. So we have this safe app running here. This is it's our React development environment running here, and I want to convert this very simple one-page decentralized app into a safe app. So for the sake of this demo, everything is in one source code file, which you probably should not do if you write real production code, but for this one, it will be enough. And the first thing that I want to do is like quickly check what we're actually doing in our safe app. So the big first magic that we do is the code that actually loads what balances are active, right? So we are using ethers to create our interfaces and to trigger our interactions with the RPC nodes. So we use, here we build together an events filter that queries all the events via a provider, which is based on our window.ethereum instance. Normally, you probably would use something like onboard.js, and this instance is created at the very beginning. So once we have all the events, we filter, we group, check that we get all the combinations of tokens to addresses, and then check for which of these addresses is where we at some point set an allowance. Do we still have an allowance set, right? So this is basically going through all of these events, querying the allowance and setting the allowance. And then we render these allowances array that we render this out. It's just a very simple script, right? We iterate through our allowances, render token, spend, and allowance, and on click, you can reset the allowance. So to convert this to a safe app, we want to hopefully make this as easy as possible, because this should allow you, if you write the hackathon, to take existing code and just bring it into the safe universe, basically. And I have some sheet notes in my README. And the first thing, which for a safe app is required, that actually we provide some information in our manifesto.json. So these information that we provide there, so it's a name, a description, a URL, and the icon path. These are the information that will be shown in our overview. So we have our name and the icon, and we actually also have the description, right? And if you click on it, we should see somewhere, oh, that might not have been the best example, might load a while. We should see somewhere where this app was coming from. Oh, actually, we should show also, I think this is one of the features that we're coming, that we also show the URL of the developers that have developed this application. So the first thing that we're going to do is we have the name, we add a description, ETHDenver app, let's call it allowance manager. And we need a URL. Obviously, we take our bounty URL. Oops. And we need an icon path. I'm just gonna take our existing icons, which currently is the nice React app example icon. So the next thing that is also very important, which we already did, is that actually you use React Rewired, because if you want to test it locally, to include the safe app into an iframe, it is required that the CORS, so the cross-origin resource sharing headers, are correctly set. And by default, the React setup, the React development service doesn't do that. So we're actually using React Rewired to get it started. So now if we kill this and do yarn start again, so I have our oh, and another part is we need to use HTTPS, because if we want to use, we want to test it with our real web interface, and since the real web interface uses HTTPS, it doesn't allow downgrading. So this is a security feature, so that it's not possible to hijack your HTTPS connection or downgrade your HTTPS connection to a lower security standard. So now that these are the very first steps, so now we should be able to at least add our Safe app into the into the Gnosis Safe interface, but we will see that it will not work yet, or it will still try to connect to my MetaMask wallet instead to actually my safe that I want to use. So what we will see already. Now it shows allowances managers. I have to accept this, and yeah, we can get re-added, and you will see this. But yeah, as you will see, this is still related to my MetaMask wallet. So if I disconnect my MetaMask wallet and reload the frame, you will see that MetaMask still allows that. Normally, at least what we should see is that we don't have access to to the address of our safe. So I think a simple way to show this also would be that we can say we add we're gonna output our owner as a wallet address. Just connected address and set connected address. And here we say, okay, once we load our allowances, we're just gonna call set connected address. Oops, and render that up. Cool. But we're gonna speed this up now. Yeah, and we see that it's not safe. So what we can do now is actually we have some helper libraries that allow us to reuse most of our code. So the first library is the Safe Apps React SDK, which allows us to handle most of the connection magic between the web interface and the Safe app. So if we take a look at the Safe Apps SDK, we can see that we provide a safe provider. And by using the safe provider, we can anywhere in our React app just use the safe, called the use safe apps SDK hook, and then access all the functionality of the safe apps. So let's add the safe provider. And we're gonna also use the safe hook to replace our magic where we connect to the MetaMask wallet to connect to our safe. So we're gonna remove all this one. We're gonna remove this one and say here, that we want to load the safe info, and then we return the address of the connected safe. So it's one too much. So now when we refresh, we should already see that the connected address should switch over to our safe. If it would work, which it doesn't. Oh, yes. There was a copy paste. So obviously we want to use the Safe Apps provider here. And then we reload our app, and then we see, okay, this time we actually see the allowances for. Still is the case is that actually, if I disable my MetaMask, we will see that we will not be able to load this this information, because suddenly our provider, which is based on our window instance, is actually not available anymore. So now what before what we had to do is like everybody or every Safe app would have to ship their own HTTP provider, so that uses the JSON RPC endpoint, for example, Infura, but that would also mean they all have to ship their own Infura key. To avoid this, we actually allow that the Safe apps can use or can channel the RPC requests through our web interface and make use of the read, at least for read calls, of the Ethereum provider of our web interface. So for this, we will use our library called the Ethers provider. So this is right now a very simple abstraction around this whole, or that encapsulates all this into a simple Ethers provider, so that we can easily reuse all our code that is based on Ethers. So if we take a look here, it will be as easy as importing the Safe apps Ethers provider. Not here. And then we can make use of it by instantiating it. So in our methods where we build our provider, we replace this to use the Safe SDK. And now our Safe app should start. Oh yeah, I need to comment this out. And now we can see that it starts working again, and then we can get our allowances again. So now we also have to adjust our reset allowances, because actually this provider is based on a JSON RPC provider. It actually doesn't have a signer. So we have to switch this out. So how do we send transaction? And obviously, or not obviously, we can use the SDK to send transaction, but right now it's not possible that we can just like replace or reuse the normal Ethers contract syntax. So we have to start using, we have to encode our calls ourselves. For that, we use the SDK, and there we have a transactions sub package where we can call send on. The send method takes an object that has two parameters. One is an array of transactions, and one is advanced arguments that are further described in our Safe Apps SDK, which you might have to use if you perform very complex transactions that are hard to estimate because certain dependencies are either not up to date yet on state, and therefore you can, like similar to a gas limit on a normal transaction, you can also here provide a hint on how much gas should be provided for these transactions. So, but for our use case right now, for the simple examples, we just provide an array of transactions, and each transactions in these arrays has a two value, which is 0 here because we do a contract call, and data. Our 2 is the token because we want to reset the allowances on the token address, and our data is a proof call, like encoded, so we can use the interface for our ERC20 token that we already used to fetch the events, and can just encode the data using ethers. So then we spender and set it to 0. And this should be all that is required to make this app work again. So now if we click reset, there we see that we trigger a transaction, and this transaction calls the reset method. So when we now perform this, we will see that Now I have to enable MetaMask again. Else I have no wallet that can execute my transactions for the safe. So let's connect to this account. And then we can submit the transaction. Now we might have to retrigger this now. So, but okay, before I show this, the other feature that we actually want to do, right? Like what would be nice is that we can have a button which is like a reset all. So let's add our UI, since we have 5 more minutes more or less. And I just want to outline how easily it's possible to actually batch the transactions. So we have a span, which is kind of reset all. And we pass in our allowances. So let's copy our logic for resetting one allowance, call it reset all allowances. As a parameter, we take an array of allowances. And what we do now is we have to build our transactions array. So we actually build it the same way as here, but based on each single allowance here. So what we actually can do is we take our allowances array, we map every single allowance to a transaction. So what we want to do here is for each allowance that we have, we take the allowance token and the allowance spender, and then can use it. So let's reload this. Oops. Our app got lost. That is not that nice. Let's add it again. So as we can see here now, we have the reset. We could submit this, which will trigger a MetaMask transaction that would then execute the safe transactions. Or actually what we can do now is we have our reset all button, which will actually create for each of our allowances a transaction that will reset the allowance. So if we now submit this, it only takes one transaction and all our allowances will be reset that are related to the safe. So hopefully this, let's see how fast. So now we can see that we should get a new transaction here. Hopefully in a second it also shows the transaction hash. But here we can now see that we had multiple allowance events. These three are allowances event where we set our allowances back to 0. And if we actually go to our, actually now also the interface decodes these transactions as where we set the allowance to 0. If we go to back to the app, we will see that there will actually be no more allowances displayed. So converting an existing app or an existing React app, or reusing a lot of code from the existing React app is very simple, and it's very easy to write new apps that leverage the Gnosis Safe interface, and therefore allow you to interact with the wide user or the big user base and the big funds or the big pool of assets that are stored in the safes and provide users with additional functionality. Obviously, not everybody uses React, and therefore actually our Safe Apps SDK, while we provide helper SDKs for the React side, it's possible to use it without React. For example, the Safe Apps ETHS provider that we have shown, it's not required to use React to use it. And it's also the Safe Apps SDK itself doesn't require that you use React. It's a pure JavaScript SDK that can be used. You can find more information on our docs there, where we also link the different SDKs and provide some simple tutorials and some introductions. And you can find other introduction videos and talks that show you how to get started. Yes, I think that would be all when it comes to the Safe Apps. If there are any questions, let me know. If you have any questions later, we are present in the virtual booth, and you can also reach us on our Discord channel, where we are happy to answer any questions that you have.
Well, let's see, Richard. I don't know if we have any questions. Jonathan, can you tell us if we do? I guess not. Jonathan, a negative is good? Well, I guess not, Richard. So thank you so much for the introduction. In fact, I've got 3 projects now that I'm using Gnosis Safe with. So we've seen some really impressive milestones from value storage in Gnosis Safe. So, I mean, I think it's a fabulous alternative to some of the other kind of components that have been out there. We're using it ourselves. So congrats on the good work. And thank you for the presentation.
Thank you very much. And I hope that somebody comes up with a very nice hackathon project from ETHDenver that allows you to leverage the funds that are inside the safes even more.
Absolutely. We'll look forward to seeing it too.
Then I wish you a nice evening, morning, actually morning for you, evening for everybody who's on the European side, and enjoy ETHDenver and get hacking.
Are you gonna? I know it's like in the middle of the night, possibly for you, but are you gonna play poker tonight or no?
Probably not, since I'm a little bit outside and I have to take care of my kids, since most of the kitas are closed in Germany and wouldn't be open right now anyways. But yeah, maybe I turn in, but it doesn't look like it right now, sadly. I would love to. I would love to play poker.
Well, tell the rest of the team we said hello, and we'll see you very soon.
Thank you. Have a nice evening. Have a nice day.
Yeah, see ya.